from higher temperature to lower temperature. Am I right? That means the heat flows from, the transfer of heat takes place from higher hot bodies to colder bodies. Unidirectional. Okay, so according to the first law, the transfer of heat energy takes place. See, if you take the system, any system which is kept at higher temperature, for example, the system is T2 having high temperature, and there is another system, so assume that there is another system whose temperature is how much? T1. This is T1. Now this is hotter body, this is cold body, and between both are connected. So what happens means the heat from this hot body means higher temperature to lower temperature, there is a transmission of heat. So this is the unidirectional transmission of the heat energy from higher temperature to lower temperature. That means why not? Or now the question is, does the thermodynamics first law talks about transmission of heat in reverse process? Do we transfer the heat energy from colder to hotter? Is it possible? Why there is only the transmission of heat from higher temperature to lower temperature? Is it possible to shift that heat, transfer the heat from colder to hot objects?
No, sir.
So that means here only the first law of thermodynamics talks about transmission of heat energy from higher temperature to lower temperature, but it doesn't talk about transmission of heat from colder to hotter. In case if you want to do this process, we require a lot of external energy we have to apply, so which is quite difficult for us. And similarly, the diffusion of the gas also. For example, if you take one container, and in this container if you leave the one gas, for example carbon dioxide gas at the corner, and the gas will spread entire this room. It occupies this entire volume of this room, we say. That means diffusion of the gas is also unidirectional. Once the gas spread in this container, does it contract back? Is it possible? Once the gas spread and occupy the volume of this container, after some time, does it come back to the small volume? Is it possible?
Okay.
So that means here diffusion of the gas occupying some certain volume and transfer of heat from hotter to colder bodies are said to be unidirectional, and these are said to be what we call means spontaneous reactions. So transmission of heat from hot to cold, transmission of means diffusion of the gas and occupy the volume of the room or occupy the container is spontaneous. Are you getting my point? I'm using two words. One is unidirectional, second one is the spontaneous. Because why I'm using the word means, so spreading the gas in the container is spontaneous. I'm using the word, right? Spontaneous means what? Okay, what is the driving force for the transmission of heat from this hotter to colder? What is the driving force for the diffusion of the gases and occupy the volume? What is the driving force? for the spontaneity change, for the spontaneity change? What is the driving force?
Difference between their pressure and temperature.
Yeah, difference between, so temperature between the two systems. That's right, difference. And so what do you say in case of the gas?
The concentration of gas was more one place and less other place.
See,
Mental.
the gas moves and it spread entire this volume. So what could be the driving force to spread? And one more here question. So the driving force spontaneous occurring changes, what determine the direction of the spontaneous change? See, this is unidirectional. Spread of the gas is unidirectional, and transmission of heat from the hot to cold is unidirectional. So what determine the direction of a spontaneous change? What determine? So here, if you want to understand the spontaneous of the reaction or spontaneous change of a system, so we have to talk about, first of all, what is meant by spontaneity. The spontaneity of a system, spontaneity of the reaction is, the definition I'm giving, what is the spontaneity? Having the potential to proceed without assistance of external agents. Here, the definition of spontaneity mentioned here, you can see having the potential to proceed without the assistance of external agency. Best example, diffusion of the gases. The molecules move from higher concentration to lower concentration without using external force. Am I right? Diffusion. If you keep that two bodies, one is hot, other one is cold, and without doing any work, the heat can transmit from hot to cold without spending energy. Having the potential to proceed without assistance of external energy is called spontaneity. Are you listening to me? What I'm talking about, spontaneity definition?
Yes, sir.
Yes, sir.
So the spontaneity means having the potential to proceed without the assistance of external energy. Does it talk about that rate of reaction, speed of the reaction? Means no. The spontaneity doesn't speak about the rate of reaction, with what speed, what velocity the reaction is taking place. And it talks about two things. One is reversible, irreversible. Most of the spontaneous reactions are irreversible. What is the meaning of irreversible? And there are two reactions are classified into two types. One is reversible and irreversible. What is reversible reaction? What is irreversible reaction?
Reaction which can be reversed is reversible.
The most of the spontaneous reactions are irreversible. Irreversible means once the product is formed from the reactants. See, reactants transform into the products, right? Sometimes what happens, reactants without using energy, without consuming energy, reactant transform into the product. Once the product is formed, the product cannot be reversed back. You cannot get the reactant again. So that means the product, once it is formed, it is a permanent. The product is a permanent. The formation of the product is spontaneous, which cannot be reversed back. And this kind of change permanent change is irreversible process which takes place in the open system. It takes place in open system, right? Most of the reactions that takes place in the nature, reversible or irreversible? Tell me. Most of the chemical reaction that takes place in the nature, reversible or
Irreversible.
irreversible, not reversible, we say. But
Yes,
if you want to bring back this product to reactant, we must reverse it. That means the reactant must be taken in control conditions. Am I right? It should be taken in which system? Can anyone tell?
closer.
It must be taken in the closed system. It must be taken in the closed system. So the conditions, if you apply the conditions in the closed system, the product will decompose to form the reactants. That means, so we must change the conditions such that to reverse the products to the reactants. Am I right? So product must be converted to reactants. So for this, we must apply external conditions, closed conditions, temperature, pressure, all the conditions. So by applying external agency, we should change irreversible to reversible. That means equilibrium reactions. Equilibrium reactions, rate of forward, rate of backward. So forward and backward reactions are equilibrium reactions, which are reversible reactions, we say. But reversible reactions are done not in the natural. They are done where means in that closed system. Are you listening to me what I'm talking about here? So two types of reactions I'm talking about. One is irreversible process, other one is reversible process. Right? Most of the irreversible reactions are spontaneous reactions. Spontaneous matlab, so those reactions takes place without external force, having that potential to undergo change without any external force, we say. But what could be the reason for this spontaneity? What could be the reason for the spontaneity means? So simple, we can tell the reason is that there is, see, the reactant transform into the product, there could be change in enthalpy. So the enthalpy of the reactants, that means we have to talk about the reason for the spontaneity is that decreasing of enthalpy change of the reactants, right? That means here, what is the reason for the spontaneity of chemical reaction is that decreasing of what we write, decreasing of, we can write, so decreasing of enthalpy change. We can give this example. That means the enthalpy of reactants decreases and enthalpy of product increases in one particular reaction. So decreasing of enthalpy change is reason for the spontaneity. Right? So a chemical reaction is associated with decreasing of enthalpy change.
Which type of enthalpy?
Yeah, so yeah, enthalpy change decreasing will takes place, and that is responsible for what means. That is responsible for what means. So and spontaneity we say. For example, you can here is decomposition of ammonia. Say decomposition of ammonia is non-spontaneous. This is, see, look at this equation, and ammonia is given here. Ammonia is a product, right? So how the ammonia is formed? Ammonia is formed when nitrogen gas combined with what? Hydrogen gas. What is the ratio of combination? Ammonia gas formation. So here 2 moles of ammonia. 1 mole of nitrogen combined with 3 moles of hydrogen. So the reaction is 1 mole of ammonia, 1 mole of nitrogen combined with 3 moles of hydrogen to form 2 moles of ammonia. For this, enthalpy of reaction how much? So here enthalpy formation will be, for 1 mole, enthalpy of formation will be delta FH naught. Standard enthalpy of this formation is, how much is given here? This is minus 46 kilojoules per mole. This is the value. Minus 46.0 kilojoules per mole is enthalpy formation of ammonia. Are you listening to me? This reaction, what I'm talking about here, enthalpy formation with respect to 1 mole or 2 moles?
The 2 moles.
2 moles. See, 1 mole, for 1 mole enthalpy of formation, then tell me delta, so RH value, how much it could be? Can you guess?
So minus 23.
No. Enthalpy of reaction, enthalpy of formation with respect to 1 mole, this is with respect to balanced equation, as per the balanced equation. So balanced equation, the product formed how much here? 2 moles. So you must to multiply this 46 minus 46 into 2. How much will be? You should multiply with the 2.
Minus 92.
Minus 92. So minus 92 kilojoules per mole is enthalpy, standard enthalpy of reaction of this ammonia formation. Clear everyone? Enthalpy formation is minus 46 for with respect to 1 mole. This is with respect to 2 moles as per the balanced equation. Are you understanding what I'm talking about? Enthalpy of the reaction. Now listen, the 2 moles of ammonia. Now I am reversing this reaction. So this is irreversible, right? This is irreversible. And if this ammonia decomposition is taken in the closed system, what happened? Ammonia decomposition. See, if forward reaction is exothermic or endothermic? Minus is mentioned, no? Formation of ammonia is exothermic or endothermic? Look at the equation and tell.
Exothermic.
Exothermic chemical reaction, very good. And if I forward is reaction is exothermic, now product. So the product is decomposing to 2 moles of ammonia, nitrogen, and here is 3 moles of hydrogen gas. If it is reversed, process reversed, is it exothermic or endothermic? Now tell me.
Endothermic.
Endothermic. So that means here, so decomposition of ammonia is endothermic. That means here, formation of ammonia, forward reaction. If it is so, that means this reaction is exothermic, and if it is this ammonia is taken this closed container, the same conditions are applied. It will be decomposing to form nitrogen and hydrogen. That means here only in the closed conditions only the reversible reactions are possible. And so in the chemical reaction, the enthalpy of the reactants decreases. Decreasing of enthalpy of the reactants is the cause for the spontaneity. right? So from this, what we understand, so from this chemical equation is that, so decrease in enthalpy is a main factor for the spontaneity. But is it for all the cases? Means we can't generalize this process. In some cases, what happen without decreasing also, and chemical spontaneity is possible. So then what could be the reason for the spontaneity of the chemical reactions? That means decreasing enthalpy is not the mainly reason for the spontaneity, and there could be other reason also. That reason is what we can say means, and what drives this spontaneity of the reactions given direction means, another reason is we can tell entropy. We should talk about this entropy. Now, understood the spontaneity, everyone? What is the definition of spontaneity? Spontaneity is so any process that takes place without external force, any chemical reaction that takes place without external factor, without external energy, without consuming any energy. So that is what we call spontaneity. And so reason for the spontaneity is that decreasing enthalpy of the system. But so some of the reactions takes place so without decreasing of enthalpy change also. And in that case, we have to use one more term that is called entropy is another word we have to use. And so now we'll talk about how the entropy is related with the spontaneity. Okay, now for understanding of this entropy, the new thermodynamic word entropy, so we have to discuss. That means without change in without change in the enthalpy also, so there is spontaneity. For example, in case of the gas, just now I told if you take one container, and so in this container, generally what happen, take this container, so this having this volume V, and in this if you leave one gas, and if you just so if you leave any gas like hydrogen gas is 1 mole of hydrogen gas uh, is kept in this room, this gas will occupy this entire volume or not. That means here the hydrogen gas occupy this volume, so and it can diffuse and occupy the volume of this container, and so during this spreading of the gas, enthalpy change equal to 0. Is there any decreasing enthalpy of this gas here? Enthalpy change? Is there any chemical reaction is happening in this? Only the gas molecule can spread. The gas molecule can occupy the volume, and there is no enthalpy change, decreasing of enthalpy change, but there is a change in the volume of the gas or not? There is a spontaneity is there or not in this case? That means here in a closed system, the gas is filled one side, it is separated by one partition, and if you remove this partition, what happens? The gas molecule can spread and occupy this entire volume. And in this case, what happens? Enthalpy change equal to 0. Delta H change will be equal to how much? It will be 0. No change in enthalpy. No change in enthalpy, but there is a spontaneity. Got the point, everyone?
Yes, sir.
No change in enthalpy, but there is a change in what means. So spontaneity we can notice in that. So that means what is happening to the gas molecules? Gas molecules are spreading. Gas molecules are diffusing in the container and occupy the volume or not.
Yes, sir.
So that means the molecules are spreading away from each other, and that molecules are moving from compact to broader, no? The gas molecules, so subjected to randomness, gas molecules are moving away from each other, and so what is the property means? What we call this is degree of randomness, or gas molecules are said to be in the disorder, not in the order, no? For example, if you take solid, molecules are arranged. In case of liquid, loosely arranged. So systematic to disorder. That means greater is the disorder of the isolated system, higher is the entropy. See, here we should apply one word, thermodynamic word, that is entropy, which is indicated with the S. This is S is the symbol for the entropy. What is the entropy means? The entropy talks about spread of the molecules, randomness of the molecules, degree of randomness of the molecule. Now, if you take one solid, for example, if you take one crystal, right? So, if you take 1 mole of crystal of sodium chloride, and in this crystal, how the molecules are arranged? Can you tell now? In the crystal, the molecules are arranged very close and compact, no?
Yes.
Yes, sir.
So that means
Yes, sir.
molecules arrangement in the crystal will be orderly arranged, systematic, compact. Their arrangement of the atoms or molecules or ions, whatever present in the crystal, will be packed. So there is order we could see. Am I right? In case of the solid.
Yes, sir.
And if the
Yes.
solid upon heating this solid, and the molecules will be disordered, means loosely packing will be taking place in this loosely packing, then it will become into melting liquid it becomes, and again this one upon heating, then so we'll get the molecules move away far away to each other, and it turns into the gas. Am I right?
Yes.
So that means here solid there is order, liquid little bit disorder, gas complete disorder of the molecules, spreading the molecules, randomness, degree of randomness, molecules become free. Then tell me what could be the reason for this randomness and orderness of the system?
Didn't I want to do courses?
Yeah, so now here how this randomness of degree of randomness of the system spread of the molecule is responsible for what means, can we write Q is the responsible? Heat is the main reason for this randomness, am I right? That means what could be the reason for the disorderedness, messiness of the system? See, so that means molecules are mess up with the energy available in the surroundings. Got the point? From where does this energy come from? So from the surrounding only, no? Means, for
Yes.
example, so the solid upon heating changing into liquid, liquid upon heating changing into the gas. That means what is supplied on the solid? Q is supplied.
Yes.
So then what
Yes.
could be the reason? What could be the reason for this messiness, or what could be the reason for this randomness of the system? Means heat is the responsible, heat is the reason, main reason, right?
Yes.
So this heat come from the surroundings. This heat come from, so we supply the heat energy, or sometimes that means the temperature difference of the surroundings and system is responsible for this entropy. So here I would like to add one more thermodynamic property, one more the state function property, thermodynamic property is entropy. The entropy as a measure of the degree randomness of a system, and the greater the disorder in an isolated system, the higher is the entropy. See, the entropy of the universe is increasing now. are you getting my point? Entropy of the universe is increasing. Positive. What is the reason? Can anybody tell the entropy of the universe? The gases are expanding. No, universe. The gases are expanding. Is it in contraction stage or expansion stage of the universe?
Expansion.
Expansion stage. That's why the entropy of the universe is increasing. Then what could be the reason? Energy is the reason for the increasing of entropy.
Yes, sir.
So that means heat energy difference. See, and you are observing one system. That system is kept in the where means in the universe. That means the system is accompanied with the surroundings also. No. See, though you are not supplying heat energy to the system, but the system itself will consume the energy from the surroundings. Or sometimes the system will be losing energy, and it will be adding the heat energy to the surroundings. So that means there is a relationship between the surroundings and the system. And if you want to talk about the entropy, you must talk about the system and the surroundings. Because sometimes though heat energy is not supplied to the system, but the system will be taking the heat energy from the surroundings, undergo change. Or the system will be giving heat energy to the surroundings, and there is increasing of entropy in the surroundings also. So simple, what I want to say from this means disorderedness, the degree of disorderedness of the system. Reason for this is that heat energy, this heat energy is related to the temperature difference. Temperature difference, we say. If there is a temperature difference, then heat energy transmission taking place. And this heat energy causes disorderedness of the system. The measurement of degree of disorderedness of the system, messiness of the system, is called entropy.
Entropy.
Is the what we call means thermodynamic state function. Here entropy also will consider initial to final. It is the state function. It is not the path function. All right.
Right, sir.
Okay, now decrease regularity in the structure would mean increasing entropy, we can write. Now, entropy, like any other thermodynamic property such as internal energy, enthalpy change, state function, entropy change also is the what we call means independent to the path. It is a state function, we say. That means whenever heat is added to the system, it increases the molecular motion and increases the randomness in the system. The randomizing influence on the system will take place because of the heat energy. Now the question will arise in our mind that is that entropy change or heat energy or both are same or different? So here the entropy change depends upon the heat energy. The heat energy depends upon what means the temperature difference between the system and the surroundings we have to talk about. That means when heat energy added to the system, it undergo randomness because it causes that molecular motions. Increasing of the randomness in the system takes place. A system at higher temperature. Now I am giving one example for understanding of this entropy. Now imagine there is a gas present. Now inside there is idle gas is present at temperature T2 temperature. Means so at higher temperature. At higher temperature the molecules are far away to each other because so at higher temperature. So what happens means Q is more and the molecules will get more randomness. The same system temperature is changed to how much? So the same system temperature is decreased and temperature is changed to how much? T1. When temperature higher to lower, so what about these molecules inside? The molecules come back to their normal state. The molecules will become ordered. So here, that means here the system changing from higher temperature to lower temperature. Now here entropy is how much means this is S2. Entropy is S2, which is higher, randomness is higher, degree of randomness is higher. And in this, entropy is how much means S1, entropy is less. That means at higher temperature always entropy is a maximum, at lower temperature entropy is a minimum. And that, so if you want to find out the entropy change, what is that? You can find out delta S, right? So now make the equation delta S equal to entropy change is equal to, what is that formula we can write? S2 minus S1. S2 minus S1 or not? So entropy change, final minus initial. So now make out that one equation, entropy change of the system is equal to, it is directly proportional to Q upon temperature. I'm making this equation. So entropy of the system, any system if you want to measure, which is equal to Q upon temperature. Now change in entropy is inversely proportional to temperature. Entropy change is inversely proportional to the temperature. So that means entropy change related with the heat energy and temperature for a reversible reaction. A reversible reaction. See, now the one important point we have to discuss in this, very important concept is why this is the main concept in the second law of thermodynamics. Now we are talking about second law of thermodynamics, which talks about entropy change, which is inversely proportional to the temperature. But why this concept has come up? Why the second law of thermodynamics came into the existence? Can anybody tell us why this? So the second law of thermodynamics has come up. Anyone? What could be the reason? Why? What is the defect of the first law of thermodynamics? Yes, are you listening to me?
Yes, sir.
Yes.
See, we were talking about the first law of thermodynamics, which is enthalpy, internal energy change. Internal energy change equal to work done on the system and plus Q, heat is released, right? Or work done by the system. So W minus Q equal to and internal energy change. That was a discussion. But what was the defect of this first law of thermodynamics? What was the defect of the first law of thermodynamics? Can anyone guess the defect? The defect of the first law of thermodynamics. The defect of the first law of thermodynamics is that direction of transmission of the heat unidirectional, not two directional. It was a defect. See, and in order to answer for that question, that means transmission of heat from not only from hotter to cold, from colder to hot also, which is quite possible in reversible reaction. Got the point? See, heat transmission takes place from where? From T2 means system from T2 higher to lower, right? Heat transmission takes place from T2 to T1, higher to lower. But in case of the reversible reaction or in case of equilibrium reactions, what happen, you know? So in cyclic process, what happen in the reversible system? What happen means the heat also takes place from where, from colder to hotter also, in case of, in the special case, in the cyclic process, in the reversible case, automatically. So that means it was given by the scientist. This idea was given by the scientist, nurse scientist. Means where the first law of thermodynamics talks about transmission of heat from hotter to colder. This is spontaneous. First one is spontaneous, okay, but the second one is non-spontaneous. But in case of the reversible condition, from colder to hotter also, the heat will take place without spending external energy in reversible case. That means, so at higher temperature, entropy is a maximum, at lower temperature, entropy is a minimum. The total change is equal to, what is total change of the entropy is, which is equal to heat under reversible condition upon temperature. That means entropy change is always inverse. Inverse we should take, inversely proportional to the temperature we say. So that is the equation I want to add here.
Sir, if temperature change is 0 even after supplying some heat.
Yeah, so see, sometimes what happen, temperature, see, already at T2 temperature gases form, okay, and already the gas is entropy is maximum. And if you change the temperature little bit, still that is in the form of gas, entropy change will be less or even 0 also. But we must consider the entropy change. See, in one particular chemical reaction. So reactants, in the reactant generally, entropy is entropy for the reactant. For example, reactants will be in the form of solid, reactants in the form of liquid, reactants might be in the form of gas. Most of the cases, liquids we say. So entropy is less. Got the point? And upon supplying the temperature, when temperature is applied to the reactants, what happens? Reactant changes into product or not? Then the products are produced in the form of gas. Entropy badega, increases. Entropy increases, no? Reactants, so changes into the product. Entropy always a chemical reaction accompanied with a chemical reaction is accompanied what means increasing of the entropy. Positive value. Products means a chemical reaction means a chemical reaction entropy always maximum. Entropy change will be the maximum because so reactants changes when temperature is applied on the reactants. Reactants undergo change, no? Their state will increases. Liquid changes to gas. Got the point? So
Yes, sir, got it.
entropy for the reaction is always a positive. It will takes place in the positive, means the state of the reactant changes from liquid to gas. Right. So that means here, can anyone tell me entropy? So zero entropy system. Is there any zero entropy system possible? Is there any zero entropy system in the nature?
Solid.
Yeah, so is there any system that has zero entropy? Is it possible in the nature? Do you achieve this one perfect? That means entropy is a zero. Mean any system that has an entropy is a zero equal to zero means enthalpy entropy system is equal to zero. Do we achieve this system means so? Entropy of the system zero in at what case means at
Zero
minus 273 Kelvin temperature minus how much 273 0 Celsius temperature.
Yes, sir, 0 Kelvin.
Or we can write Kelvin 0 Kelvin temperature and in this case, so the solid or and the means the molecules will be completely order. It assume it to be zero, but not achieving this is not possible. Or simple, I want to say the pure crystal at low temperature will have this entropy is zero. But do you achieve the pure crystal? So 100% pure crystal is possible means we can't prepare. So here entropy value talks about orderness, and if the system is in order, that means so heat energy is not supplied. If the heat energy is supplied to the system, it causes molecular motions. It try to get the randomness. So reason for the entropy is that heat energy difference, right? So this is the entropy thermodynamic state function of the second law of thermodynamics, we say, and rest of the things. So we'll discuss in the next class about one more Gibbs energy and the thermodynamic property.